Good afternoon everyone and welcome back to my channel. So in the last video I pretty much explained the mathematics behind the Monty Hall problem, and I said I would do a coding edition of the problem. So this is what we are going to do today. So I'm going to try and program it in front of you guys just to have a better idea of how the program works pretty much. Right, so to start with, we are going to use a random variable to choose the doors with the car behind and also the choices of the two players. So we can have two players who are one which is always going to stay with his choice and the other which is always going to switch, and they are going to play a certain number of games, and we're going to see which percentage of the time they're going to win and which percentage they're going to lose, right? And also just to make it a bit more interesting, we're going to give them the possibility to open more doors. So just to see how the game would run with, for example, 1,000 doors, this could be interesting to see. So that's what we're gonna also allow them to do. Right, so to start off with, we're gonna import random variables just to be able to use that, and we're gonna create a function called Monty Hall simulations, and with two parameters. So these parameters can have, so we're going to input the number of doors we want to have in our games and the number of games we're going to have. So num doors, and we're going to have num games as well, right? And now, so we want to see how we're going to set these two variables. So we're going to set switch wins. So we're going to have two users, one called switch and one called stay, and both their wins are going to be set to 0 first. Set wins, and then we're going to add to those as they win the car or do not. And then, right, so then we're going to set create a for loop to run the number of games, and we don't actually need anything here. So for something in range, so we want it from number of games. So we're allowing the user to run a bunch of games right now. So we might do 1,000 games, which is going to give us a more accurate probability of what's going to happen. And right now, so to represent all the doors, we're just going to use a simple array. And instead of having goat and cars in behind the doors, we're just going to set them to 0 for goat and 1 for the cars. So represents a goat and 1 represents a car. So we're pretty much simply gonna create an array called doors, and we're gonna this array is gonna be an array of zeros. Oops. And we want how many doors? We want num doors of doors, right? So now we're going to pretty much get an array of this type. Well, right. And so now we need to randomly input a car anywhere. So we're gonna generate a random number under the name car door, and then change this random 0 to 1. So car door is equal to random.randint. We're gonna, since the arrays start with 0, we're gonna pretty much make it more easy by using num doors -1 in this case. Num doors -1. So we're starting from 0 to num doors -1. This is just gonna set everything a bit easier. And now we are simply gonna change the value in the array of doors. So the value of the car door is just going to be set to 1. The value of the door with the car to 1. Right, so I hope this makes sense so far. And Right, so now we've pretty much set everything, set up a game, and now we're gonna create the two users, so switch user and stay user, and those guys are going to pick a door at random again. So switch user and stay user, so switch user, new variable, because we're pretty much the same, random.randint, between 0 and num doors -1 again, and stay user is going to be pretty much the same, random.randint between 0 and num doors -1. And right, so now they've picked the doors, and we're going to check, and right now we're almost done, because we actually don't really need to code the entire part where the game host closes all the doors, because I mean, if you think about it, as soon as the switch user makes a choice, then this choice is just gonna impact if he gets a car or not. We'll see later on. Like I'll explain this as we go. So now we're just gonna check if the doors. So if the switch user, so we're gonna consider the switch user case first, right? Let me just write this. Consider the switch user first. So if the switch user gets the car in the first guess, and he's always gonna switch, this means that he's always gonna lose, right? This is what I meant earlier. So if switch user doors the switch user equals 1 equals 1, then he's forcibly gonna lose. Like he cannot win. This is a given. So we're just gonna, we can either do nothing, but just to make it clean, I'm just gonna increment switch wins by 0, and then else, this means that switch user has actually not gotten the door on the first guess. We're gonna increment switch wins by 1, since he shall next switch and therefore get the car. So in this case, did not get the door, did get the right door first guess, and in this case, the user got a goat door for the first try. Right. So once again, if the user who's always going to switch gets a car door in the first guess, then he's going to switch and get a goat door in the second round. And if the user who's going to switch gets a goat door first, then he's going to win the game, since he's going to switch and then get the car door. Right? It's this simple. And same with the stay user. So if doors stay user equals, so in this case 1. So in this case, the stay user has gotten the right door at first guess. The stay user got the right door first. Then this time, the stay user is going to win the car. Right. Goodness me, this is annoying. There we go. And otherwise, he shall not win the car. Stay.wins will be incremented by 0. Let's just set this to make it more intuitive, right? And then we're pretty much done, right? So now all we need to calculate are the percentages. So switch, so we're going to create a new variable, switch wins percentage. We're going to set that to switch wins. We're going to divide that by the number of games played, obviously. sorry, by by the number of games played, and we want it in the form of a percentage, so times 100, and same with stay wins percentage is equal to stay wins divided by num games, once again times 100, right? And right, so we're pretty much done. We'll just actually output them here. So this cannot be in the loop, right? This should be still in the function but not in the loop anymore. And right now what's left is the number. We just need to print out the results. So results after num games with how many doors? Well, num doors, right? And right, so these are the results. So we're just telling the user how many games they played with how many doors, and we're going to print the same win percentage after switching. Yeah. So this is for the switch user, and she's going to get switch win percentage, and then boom. That's oops. This should be on the other side, and same with the stay user. So win percentage after staying, right? And then here's gonna have the stay win percentage, and we're gonna close this, and good. And now all that's left to do is run the function. So we're gonna set num doors is equal to 3 doors for the start, and then num games is equal to, I set it to 1,000 for now, so we see actually who wins the most. And we're gonna run Monty Hall simulations with num doors and num games, right? Right, so this should all work properly. So as you saw, there was no need for the second half of the game, really, where the game show host closes all the doors, and really we didn't need to code that at all, since our users will always either stay or switch. And that really kind of goes to show how this is not actually two choices but one, and the fact that if you choose to switch or stay after the first choice is really just like a simple follow through. So let's run our simulation with 3 doors and 1,000 games, and as you can see right now, we got pretty close results to what we were expecting. So the switch user had a 66.5% chance of winning, so he won pretty much 2/3 of the time, and the stay user won just a bit more than a third. And so we can pretty much see, if we keep running them, these are pretty much always gonna stay the case, and that it is indeed not a 50-50 chance afterwards. And if we want to make it more interesting, we can always make it put 1,000 doors here with 1,000 games, and we can see in this case that instead of being 2/3, it's going to be 1% with 1%, even less, 0.1% with 99.9%. Obviously, let's run it again, and this one, yeah, see this one, unfortunately the stay user did not win a single time in these 1,000 games, and we can even put it back down to 3 doors and put it to 10,000 games, and it's going to take a little more time, 66.8 and then 100,000 games. So you can see that these results are indeed confirming the mathematics that I explained in the first video. Right, so I hope you guys found this video interesting. I hope I made myself clear. I shall put the code in the description below if you'd like to test it yourself, or if you've got better codes, or if you find more interesting ways to code this, then by all means let me know. And right, so if you have any suggestions on what kinds of videos to do, literally let me know, and I shall see you guys next time. Thank you for listening, and bye bye.